Welcome to episode 21 of my calculus series. Today, we're tackling partial fraction decomposition, a powerful tool to simplify integration problems. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. Partial fraction decomposition is a technique for breaking down a rational function, that's a fraction with polynomials on top and bottom, into a sum of simpler fractions. This makes integration much easier, especially for complex rational expressions. You can use partial fractions when your integrand is a rational function, meaning both numerator and denominator are polynomials. The degree of the numerator is less than the degree of the denominator. If the numerator's degree is equal or higher, perform polynomial division first. Types of factors in the denominator. There are three main cases. Distinct linear factors, for example, x minus a times x minus b. The decomposition looks like capital A over x minus a, plus capital B over x minus b. Repeated linear factors, for example, x minus a to the power of n. The decomposition includes a sub 1 over x minus a, plus a sub 2 over x minus a squared, and so on, until a sub n over x minus a to the power of n. Irreducible quadratic factors, like x squared plus px plus q, which can't be factored further. The decomposition form is ax plus b over that quadratic expression. General steps. Step 1. Make sure the numerator's degree is smaller than the denominator's. If not, divide first. Step 2. Factor the denominator completely. Step 3. Write the partial fraction form based on the factors you have. Step 4. Multiply through by the denominator to remove fractions. Step 5. Solve for the unknown constants. Step 6. Integrate each simpler term. Keynotes. Partial fractions only work for rational functions. They're especially useful for complicated fractions in integration. And if you have an improper rational function, divide first before decomposing. Example 1. Let's evaluate the integral of 5x plus 7 over the product of x plus 1 and x plus 2. Since the denominator is already factored, we write a over x plus 1 plus b over x plus 2. Multiplying through by the denominator gives 5x plus 7 equals a times x plus 2, plus b times x plus 1. Plugging in x equals negative 1, we find a equals 2. Plugging in x equals negative 2, we find b equals 3. Now we integrate. 2 over x plus 1 integrates to 2 natural log absolute value x plus 1, and 3 over x plus 2 integrates to 3 natural log absolute value x plus 2, plus c. Example 2. We're integrating x squared plus 5x plus 6 over x cubed plus 3x squared plus 2x. First, factor the denominator. X times x plus 1 times x plus 2. Write the setup. A over x plus b over x plus 1 plus c over x plus 2. Multiply through. Plug in x equals 0 to find a equals 3, x equals negative 1 to find b equals negative 2, and x equals negative 2 to find c equals 0. That gives us 3 over x minus 2 over x plus 1. Integrating gives 3 natural log absolute x minus 2 natural log absolute x plus 1, plus c. Example 3. For the integral of x squared over x squared minus 1. We first divide, getting 1 plus 1 over x squared minus 1. Factor the denominator into x minus 1 times x plus 1. Write a over x minus 1 plus b over x plus 1. Solving, we find a equals 1/2 and b equals negative 1/2. Integrating gives x plus 1/2 natural log absolute x minus 1, minus 1/2 natural log absolute x plus 1, plus c. Summary. Remember, partial fractions break complex rational expressions into simpler ones, making integration straightforward. Different denominator factors have their own decomposition forms. And that wraps up today's episode on partial fractions. If this lesson helped you out, a like, follow on TikTok, or subscribe on YouTube really helps me keep making these videos. Thanks for watching, and I'll see you in the next one.